Great. So just quick housekeeping here. Tim and I love to talk to each other and can go back and forth, but we want this to be as informative and interactive as possible. If at any time you have questions, please use the Q&A function of the Zoom. It also seems like it's being recorded, so if you have to step away for any part of it or need that, just reach out to the organizers to get that. So please don't hesitate to reach out, and I'll be monitoring. In terms of what we're going to be covering today, first we'll be looking at the API threat landscape and really explaining why is this so critical right now? Why is now the right time to be thinking about API security? Second, we'll make it very tangible and show and kind of walk through very real API security incidents and how they happened. Then we'll start shifting towards what do we do in response to that? How do we get better about API security as a community by looking at an API security maturity model? And finally, going over API security checklist, where you can start and get going. Then we'll conclude with how Wallarm can be of help if it makes sense for your organization. Let's go ahead and jump in and take a look at the API landscape. I think it should be no surprise that the amount of APIs that are out there is growing very, very rapidly. But I think we also need to understand that when you hear the word cloud computing or artificial intelligence or mobile applications, that's all code for APIs. So when you learn or hear about any innovation or investment in those items, you know that that's only amplifying the amount and the kind of the sensitivity of those APIs. Tim, walk us through the tech stack here and all the other things that are kind of adding to the proliferation of APIs.
Yeah, Chris, I don't think you intended it there, but the that's all code for APIs was a pretty good pun you worked in there, unintentionally perhaps, because that's what it is. It's all code for APIs. I really like this iceberg image that we have. We've used it for a while, but I feel like it really describes the situation, the reality that most organizations face. When you think about the APIs that you have, you often think of those, if you're an organization that develops applications, you think of those public APIs that you know are exposed, that you're pretty aware of because they're part of how you do business. But the reality is that that's just the tip of that iceberg. There are innumerable other APIs that exist within the organization. Some of them are, private APIs inside the org for exchanging and connecting systems internally. Some of that you either expose or consume. All of those go into that rapid expansion of the API economy, if you will, that makes up that number 1.7 billion active APIs by 2030. I suspect that if we were to revisit that particular statistic, it's probably gone up by now, given the explosive growth. And when we ask ourselves, what's behind that growth in the use and deployment of APIs, it really is this modern technology stack. The tech choices that organizations are making today ultimately are driven by and bring along APIs as a core part of what organizations are deploying and using. And there's another aspect that I think is really important, which is that high speed of innovation. So I think we all feel like we're being asked to do more faster on a daily basis. Same with development, right? As developers and as organizations that are development driven, we're pushing for higher velocity. In order to achieve that higher velocity, we're looking for efficiencies, which are often driven by the use of APIs. So the more APIs you use, the more connectivity between, programmatic connectivity between services and products, the faster you can develop and deliver. And all of that contributes to that growing API landscape.
Yep, and the more that you're leveraging these APIs, whether they be public or private, the more chance there is for APIs to leak, for them to be misconfigured, and for them to be the target of attacks, which is kind of the next thing we wanted to look at.
That's right, Chris.
You look at the breaches and vulnerabilities over time, it's growing exponentially.
Yeah, and I think you're drawing the right connection. That previous slide was about the API landscape itself. And that API landscape contributes to the threat landscape around APIs, which then results in sort of, this picture that we have here. So this data actually comes from our quarterly API threat stats report. So Wallarm, every quarter we examine and analyze all of the API related vulnerabilities and incidents that occurred within that quarter, and we produce this report. There's a report and there's a whole separate webinar uh, on the data there. So we just pulled out a little selection here to give you a sense of what that threat landscape looks like. And Chris, you noted the increase. So let me explain what's on the slide. On the right-hand side of the slide, we have the count of API related vulnerabilities, specifically CVE IDs, because those are the vulnerabilities we can count. Uh, sort of measured annually, in Q3. So it's a year over year comparison for Q3 basically. So when we did the analysis in 2022, we had 203 vulnerabilities. In 2023, there were 239. And now in Q3 2024, there are 469 API-related vulnerabilities, which represents a 96% increase. So that's an increase in the number of known vulnerabilities that are API-related that are discovered there, discovered in that quarter.
Yep. And on the left side, you can even see that even just a single vulnerability on a single API can impact hundreds of millions of users. So when you have this proliferation of APIs, this increased threat landscape, the impact to businesses and to your end users and customers is also growing.
Yeah, and I think that totals out to, if I remember, 344 million compromised users or records, depending on how you want to count it, in
Yep.
those incidents. And those are the incidents, those are the breaches that we know about that occurred in Q3.
Yep. So let's double click into a few of them, Tim, and maybe walk us through kind of what happened here and and how people should be thinking about these vulnerabilities.
Yeah, absolutely. So there are two things I'd like to point out about vulnerabilities and incidents. Um, and it's on some level it's the same thing in two different aspects. We can only report on what we know about. So if there are vulnerabilities out there that are not assigned to CVE ID that nobody knows about, so-called 0 days, we can't count them, we can't analyze them because we don't know about them. With incidents, there's a corollary situation. We can only examine the incidents for which we actually understand something about the root cause. So if there's an incident and there's no information about what caused it, it might be API related, it might not be, we don't know. So these are the incidents for which we have information. And we can start with T-Mobile, Deutsche Telekom. Uh, and here we have a situation with unauthenticated access to an API. There were 252 million user records that were scraped or available from that unauthenticated API. And it's a pretty simple, straightforward situation where you have an API endpoint that should have been authenticated and was not. And the interesting thing about this is not just the unauthenticated endpoint, but the speed at which the attackers were able to extract data. So, you clearly have the need for API discovery and assessment to understand that endpoint is there, but also it demonstrates the value of having API rate limiting in place, so that if an attacker does find that unauthenticated endpoint, they can't extract data as quickly as they might like. And that can be a valuable control there as well. And then in the middle, actually, I'll talk about the one on the right as well. So Explore Talent also was on unauthenticated access. Explore Talent is essentially a talent management organization, like, for actors and that kind of thing. But big, 11.4 million users were exposed, again, from an unauthenticated API. So this was similar to the Deutsche Telekom incident, and it really just sort of doubles down on the idea that you have to start by understanding what APIs and endpoints you have in your environment, and then you can work on assessing whether or not they're protected effectively. So then in the middle, we have two companies actually, Hotjar and Business Insider. Hotjar is a product analytics tool. Business Insider is obviously a media company, news. They both suffered client-side vulnerabilities that resulted in uh, um, compromised records, different amounts. I'm trying to remember. I think the total there was, let's see, it was in the millions. It was 80 million total for both of those. And here we had OAuth mismanagement and cross-site scripting. And the reason we combine these together is because they're both related to not server-side issues, but client-side issues. And that's something that ultimately gets ignored by the OWASP API top 10. So a clear indication that there are vulnerabilities out there that we're not addressing correctly or effectively with some of the standards that we have in place.
I think moving forward, I think let's figure out how do we get here? How do we get
Yeah.
into a situation where where such big, you know, big attacks or incidents could occur? I think it's when you look at the landscape. Obviously, you have hundreds of APIs and all these endpoints, but APIs have been around for quite some time. So oftentimes you have older deprecated APIs that we call zombie APIs. You have legacy APIs. You're obviously building things very, very quickly. And with quick hot fix that you're trying to get in before the holidays or because of a customer need, that APIs oftentimes go unmanaged and are left out in the cold and forgotten about, which are there until some attacker sniffs them out and finds them, or just maybe Tim, you can jump in and add a little more color here, but it's not just because we have so many of them. There are so many natural things that happen in our working lives where we can make this problem bigger if we're not constantly looking for ways to figure out what APIs need to be carefully managed.
Yeah, and I think the image on the slide here is useful as an illustration. You have on the top section you've got APIs that are managed. So they're in this case they're all managed through an API gateway or an API management tool. But even in that case where you have managed APIs, you still have endpoints that might be mismanaged. So when we talk about endpoints, zombie APIs, shadow APIs, we're talking about comparing what's deployed in the environment to the specification that indicates what should be deployed in that environment. So a zombie API is one that you removed from your specification but didn't remove from the environment, and now it's a risk. A shadow API is one that is in your environment but was never in the specification. So a developer built this API endpoint, it got deployed but never put in the spec. Those present risk even in an environment where the APIs are managed. And then you have the unmanaged APIs, which of course you may or may not know about. And finding and discovering those APIs, let alone the endpoints behind them, is important. And they create risk again by being exposing data that you don't know is being exposed. And then this last bullet point, everything is changing. It seems kind of obvious, but it actually is really important because we can put up an image on the slide and it's a static image and it can explain what shadow and zombie APIs are and unmanaged APIs, but ultimately it's not a static image. Development continues to build and push things to production, so what's on the slide changes constantly, and so you're creating and removing risk, ideally removing it, but creating new risk constantly over time. So it has to be a continuous process. And that type of API sprawl that we're talking about, that's what creates a lot of the risks that are present for APIs.
And I think you day in and day out, and myself as well, we're constantly meeting with customers. We're constantly helping them address this. But rarely have I ever seen it where they had an idea of what their API landscape was, what their API, estate was, where we were able to validate it and be just that. Usually it's orders of magnitude higher than what they were thinking when we finally go out
Exactly.
there and see that. And then again, that's a period in time. Weeks
Yeah,
later or months later, it could be radically different yet again. So it
you're right.
does need that constant care and
Yeah.
attention.
Yeah. So what do we do about
So
it, right? That's the
that
question.
exactly. So what we're going to be doing is kind of going through some of the best practices from these five organizations. If you're not familiar with all of them, the first one is the OWASP organization. It's a community organization that we actually are corporate contributors and supporters of. They constantly release the OWASP Top 10 and the OWASP API Top 10, which are the largest web application and API threats that are out there. So they're constantly they're the leaders of this type of research. MuleSoft also has some. They're one of the leading API gateways that are out there. So they have the top 5 API security best practices. Forrester and Gartner are two of the leading analyst firms that cover API security. And obviously there's us Wallarm, and we do our API threat stats on a quarterly basis and are monitoring what we believe to be the top 10 threats there. So what are the best practices in aggregate from these 5 organizations? Tim, walk us through the findings here.
Yeah, so behind this, there's a spreadsheet where we laid out all of the details and then categorized and analyzed them. And this is the combined uh, categories for best practices from those 5 organizations. And it gives you a sense of how they break down, where the emphasis is. So if you're thinking about where you should focus, these are the categories, right? Secure design gets the largest number of recommended best practices at 28. Threat protection is number 2. API discovery, bot protection, secure test. Market about secure testing or security testing or API testing, yet it's the best practice that's least recommended. Most recommended is secure design. So obviously, the strong preference towards deploying secure API to start with, and then protecting them once they're deployed. That's kind of my takeaway from that. We can take this to one layer lower. So these the problems underneath those level categories, and a clearer sense of where those practices also gives you a sense of might be bigger than other protection. And probably escalates the count protection. In secure design, similar got a bunch of different things, some of which are bigger. Centralized governance is a big topic. Encryption is important, but probably a smaller topic than centralized governance overall. Um, and then security testing, all of those 3 are relatively big. Interestingly, I think bot protection gets separated from threat protection. We separated it as a category, but they're very closely related. API abuse. If you're protecting yourself from API abuse, that really could fit into the threat protection category, I think. But this gives you a sense of how those break down. And then what we wanted to do with this was not just consolidate best practices, but turn it into some sort of guidance. Essentially, we wanted to turn it into a maturity model. And this is where we ended up. So across the bottom, you have, then we categorize the maturity level so you can kind of assess yourself. Where do you fit? And then what controls are most important for your stage? And then what I really find interesting is the top section, that this really breaks down into 2 types of organizations. Either you're an organization that is, in terms of purity, that's developer driven, or you're one that's security driven. Um, Smaller, earlier stage, less mature organizations are probably going to be more developer driven, meaning that the developers are the ones who are thinking about and responsible for securing those APIs. So picture of the maturity level. Chris, have you looked at this maturity model? Have you spent time on it? How do you feel about the way this breaks things down?
I think it makes a lot of sense. I think for most organizations that are developer driven, they're moving so fast that a lot of the secure design discovery are going to be things that can be looking at on an ongoing basis. And
Hmm.
again, we'll probably talk about this again a little bit later, but when we talk API discovery, it's very easy to think about that where the answer is potentially a number. That's not how we tend to think about it in security. It's understanding that the analogy I often use is API discovery is not about asking, how many children you have or how many APIs you have. It's what are they doing, right? In order as a parent to feel safe, it's understanding who has access to these APIs. What are they actually doing? That's really focused in the developer driven model because that is changing so fast and so dynamic. So understanding that from a discovery standpoint, who has access to the APIs? What are the APIs doing? What information does that API have? Is going to be very, very critical there. And when you're more security driven and a little bit more mature there, that's where you'll see focus on some more of the nuanced side of things, like Tim was talking about, like security testing. But I think it's the blocking and tackling of the API discovery, the threat prevention, and threat detection rather is generally where most people need to start and focus.
Yeah, and you'll notice that the categories span multiple stages in the maturity model. So API discovery
Mm-hmm.
is still important when you're with your first APIs. It's just the particular aspects of API discovery are less important. So maybe with those first APIs, you really are trying to just understand how many APIs you have and create that catalog. As you mature, you need to know more information about those APIs in order to actually assess them for risk. Um, One of the challenges I think that organizations can run into is that they haven't followed the maturity model. And so they're at a position where, let's say they're in a mature API environment, but they haven't done some of the first things that they need to do, some of the secure design pieces or implemented API discovery. Maybe they're doing testing, but they're not doing threat protection. So that maturity model is also an opportunity for you to look back and say, what did we miss along the way that we need to implement now that we're further along in terms of our maturity?
Yeah, and maybe some of our salespeople will disagree with this statement, but API security is not a tool, and I do like that it is presented as a maturity model. It is a process. It is a program that you are running for this one. I think moving on to our
Yeah, it's
next
a good
slide,
transition.
you'll see that there isn't a single. You may have a WAF or a WAP or a gateway or even a maybe you've invested in an API security tool. Just because you have those does not mean that you are leveraging them appropriately.
Yeah, absolutely. And I think this is a point of
ये तुम अपनी
a
तरफ से
fair amount of confusion in the market. And I actually don't expect this confusion to go away because to be honest, you have vendors who are trying to define themselves into a particular space. And as vendors, we want to define ourselves into a space where customers have budget and a problem they want to solve. Ultimately, that also creates confusion for those very customers who we're trying to serve. So if you look at traditional web application firewalls, they do a few things well. Generally, they're good at protecting against that original OWASP top 10. They're focused on web applications. They can block malicious traffic. They're often, it's not on the slide here, but web application firewalls are usually deployed as a perimeter tool as well. So they tend to be good at those public facing APIs, but you don't generally deploy a WAF somewhere in, or sorry, public facing applications, but you generally don't deploy a WAF inside of your organization in most cases. But there are some things that the WAFs are not good at. And one of them is API security. So web application firewalls were built for web applications. They often don't understand API protocols. They don't necessarily look for the same types of attacks. They don't do a great job at bot management, whether it's web app bots or bots targeting APIs. So the evolution from the WAF is the WAP, the Web Application and API Protection Tool, which comes with all those features of the WAF, but expands to some of that bot management, start to expand to API protection. So maybe they understand some of the API protocols. But those WAPs generally don't cover the whole OWASP API top 10. They generally don't do API discovery and inventory. So remember, as an evolution of the WAF, they have sort of a core architecture. And they don't do a great job with business logic flaws, which are so important for API security. And then coming from a different angle somewhat is the API gateway. API gateways or API management, they're fundamentally not security tools at their core. They're governance or management tools, but they do offer some security related capabilities. What API gateways tend to be really good at in the security space uh, is authentication, sort of centralizing authentication, ensuring that encryption is in place is a key capability for them. They sometimes do some rate limiting, but they also don't generally do API discovery and inventory. So they can only see the APIs they know about that you've directed to them. And they're generally not focused on protection. So API gateways don't detect and block attacks, which of course is a key component for API security. And then that's not to say that the API security tools do everything. We're not talking about as Chris said, API security is not a tool. Um, API security tools do focus on that protection piece. So if you're looking for an API security tool, you want one that can actually block attacks. That's a key component. They offer the discovery piece as a key capability as well. So finding all the APIs, assessing them, providing a posture assessment, and then detecting and blocking attacks. API security tools generally don't provide authentication and access control. So that's more the purview of the API gateway. So hopefully that gives you just a sense of how the tools are different and what different tools, what capabilities different tools offer that are related to API security.
Yeah, I think echoing back to the maturity model, I think when you look at organizations that have really strong API security programs in place, there is an orchestration and relationship between all these different tools, right? Where most of them actually have very strong integrations with each other, and they're ultimately using all of these controls and features together to ultimately deliver that API security uh, solution for your organization. None of these tools are a silo, if you will. So keep that in mind as you're exploring ways of building an API security program in your organization.
Yeah, absolutely. Absolutely.
All all right, we're moving now on to the API security checklist. Tim, what is this document that here? But what is this API security checklist?
Yeah, absolutely. So there will be a link at the end to the actual document. This is a tool that we put together because we saw a gap in the in the market, in the availability of something like this. There are lots of checklists out there. Customers, organizations tend to find this checklist format pretty useful. And we felt like there wasn't really a good API security checklist. So we created one. And it's really a tool for you to perform an assessment within your organization of how your API security program stacks up. Are you protecting yourself against the things that are most prevalent in the threat environment? And we're not going to go through all of them. They're listed here, all of the items in the checklist. We'll pick out three. We've picked out three to go through just for the sake of time. But all of them are included in the document itself, which, as Chris said, we'll have a link for at the end. So
All
let's
right,
take a look at the first example here. Uh, so we've got improper API asset management and discovery. We talked about the need to understand what's in the environment a little bit already, and I'll just anecdotally I'll add. Wallarm has been doing these regional API summits, API security summits, we call them, where we get people together. It's usually between, sort of 40 and 60 people for each one of them. And we have conversations about API security. We bring in external speakers. Without fail, every single one of those sessions, and I think I've done 7 of them now, API discovery comes up as the number one recommended thing to do first. Uh, so it's really a clear consensus from the community that understanding what's in your environment is the key starting point for API discovery. But what does that mean? So that's what's up on the screen in terms of a checklist. It means making an inventory of all of the API infrastructure you have from testing to production. So understanding not just the APIs, but what's supporting them. Ideally, you want to inventory who can access all of those items as well, so that you understand not just what you have, but who has access to it. Um, and sort of the gold standard there is to be able to connect uh, the APIs and infrastructure that you have back to your business. So understanding what business functions they support is a key piece there. And then that API discovery that you're running needs to be continuous. So we talked about change in the environment. You can't do if you do a manual inventory, that's a good start, but it's going to be out of date very quickly. So being able to run continuously so that you can capture changes, so that you can see when things fall outside of what you expect to be there, that's important. When we talk about documenting your APIs, the best way to do that is through standardized API specifications, so that you can actually have a document that describes what should be present in the environment, and that gives you the opportunity to compare what should be there to what is there, and that allows you to discover those shadow APIs, those rogue APIs as we call them, and then separating your production data and your testing data or your non-production data prevents unintended data disclosure, which, as we saw in a couple of incidents there, sort of data disclosure through um, unauthenticated or unknown APIs is a real problem in terms of incidents. So the second one we selected here was the API abuse, lack of resources, or rate limiting. Uh, and this is an interesting challenge because it's often not a typical vulnerability in an API that creates this opportunity for attackers. It's business logic abuse. It's the abuse of resources. So, the API calls that an attacker is making might be perfectly valid. It's just that they're making, thousands and thousands of them per minute, more than you expected. So when you look at the threats when you do threat modeling essentially for your APIs, understanding where resource exhaustion might occur or where this type of API abuse might occur is an important aspect. Uh, Ideally, the application itself, the API itself, provides some protection here, but I think the reality that we've seen is often it doesn't. So implementing rate limits for the endpoints in your environment uh, is a really powerful tool for just making sure that whatever an attacker can do, they can't do very quickly at high volume. And rate limits, can be done as the number of requests per second. You can also implement request size limits, that kind of thing. Interestingly, when you talk about specific protocols, you could talk about GraphQL. If you're using GraphQL, it actually provides, I mean, part of the benefit of GraphQL is that it provides really scalable access to data, but that scalability can also be taken advantage of. So you can actually implement some of these limits inside of the GraphQL protocol or specific to the GraphQL protocol as well. And that's different from just a straightforward request rate limit. One request for GraphQL can actually return lots of different data, which is important to understand.
Can I
Um,
jump in real
yeah,
quick, Tim?
please go
I
ahead,
think
Chris.
I think one thing just to add here is, and I know oftentimes when we talk about cybersecurity, we're always talking about the concept of an attacker. You can even see the iconography of an attacker here. But I think rate limiting is also just really important internally, just because there are sometimes without these limits, unintended consequences of growth and innovation, where it can topple things. There are so many of these incidents that occur where there wasn't even an attacker. And I think Tim and I know this quite well, where it's just sometimes there weren't these protective measures in place, and an organization trips over themselves by not having these things in place. So, yes, it's great for limiting what a potential attacker can do, but sometimes API abuse and other challenges can happen very, like you were saying, just very normally. It's the intended use of the API, but your growth and uh, it can be a stumbling block at sometimes when you don't have those protective controls in place. So it's not just to stop attackers in many of these incidents that you hear about.
No, I think that's a great point. Great opportunity there is for sort of runaway automation to create problems. Absolutely, absolutely. There's another one on here that I want to call out because it's my favorite type of control. It's boring and effective, which is blocking traffic from unwanted geographical regions or data centers or Tor exit nodes. Um, Blocking traffic wholesale from a complete country or a whole, data center. It's not very exciting. It's not the most sophisticated type of control. But if you don't expect any of your business to come from, China or from some other country, just wholesale blocking traffic from that country or that geographic region can really have a dramatic impact on just the resource consumption or resource strain that you might have in your application. And the same for data centers. If your business is such that you don't expect any of your customers to hit your API coming from an AWS source IP, then you can block all of those, and then you save yourself any particular resource consumption from those sources. And it's a blunt instrument, but it can be very effective in the right circumstances. And so I think it's part of that overall abuse, lack of resources, and rate limiting checklist item.
All right, let's move on to injections.
Yeah, the last one, classic attack. Interestingly, we include injections in our checklist. The OWASP API Top 10 which was last updated in 2023. They made this interesting and we'll say controversial move of getting rid of injections as its own category and moving it into a separate category that sort of rolled up a few things. I think it's the unsafe consumption of APIs, if I remember correctly. But the data that we have, the attack data that we actually see, continues to demonstrate that injections are just really a low-hanging fruit. And the part that's most frustrating is that we know how to protect against them. You have to build applications that validate and sanitize the input from the client. This is not new advice for APIs. Injections are not specific to APIs. It's just that they're one of the attack types that continue to pay off for attackers across multiple technologies, including APIs. So when we talked about the maturity model, that secure design category, validating and sanitizing input is absolutely part of the secure design category. Now, having said that, we know that it doesn't happen. APIs are not always built with that validation. And so putting in place protection capabilities, as we said here, API threat prevention tooling that can actually block injections is really important because they're going to happen. You're going to see them. And detecting them is not enough. You have to actually just be able to block them. And it's not rocket science in most cases. Yes, there are injection attacks that are designed to bypass security controls. That's where our security researchers spend their time, unpacking and making sure that we can detect and block those. But if I'm honest, I think the reality is the majority of injection attacks are pretty obvious attacks that should just be blocked, detected, and blocked
All
on.
right, we've given a lot of homework
So,
to
yeah,
people. There's all these things you need to do. There's all these checklists, but you're not alone. You're not on an island with this. This is something that we spend all day, every day working with our customers on, and uh, this is something that we can do to help.
yeah.
Tim, walk us through exactly how our API security platform helps organizations kind of address many of those issues on that checklist.
Yeah, so let's talk about the wall arm off the platform with a number of capabilities that are all integrated into that one platform. Form our API attack surface discovery, which is a good starting point, as a completely agentless zero deployment approach. You give us a domain name, and we go out and search for APIs related to that domain, external APIs, and give a picture of your API attack surface. And then the capabilities beyond that are performed based on traffic assessment. So you can deploy a Wallarm node, as we call them, or we can deploy them for you in our security edge. We can host and manage those. And they look at traffic and then do all of the other things that are up here. So they discover the APIs and endpoints. They provide you with a risk assessment of those endpoints. They monitor for change. They tell you if there's sensitive data in the endpoints, et cetera, et cetera. And then we also detect and block attacks, both the OWASP API security top 10 and the API abuse, more common. We have options for your environment. So if you want to deploy as a Kubernetes ingress controller, we support that. There's a Docker container. There is, of course, as I mentioned, the completely hosted and managed security edge option. And then we integrate with the tools that you're using in your environment, whether it's CI/CD tools or a SIM or various alerting mechanisms. And then Wallarm also offers a security operations center to help you um, monitor the platform itself and the attacks coming across as well. And there's excellent support behind that. So a really powerful platform with lots of capabilities. And I think, Chris, we're going to spend a little bit of time on sort of the high level pieces of that
Yeah,
platform,
why
right?
don't we jump into them? Take it away.
Yeah. So we start with discovery. As I mentioned, there are really two types of discovery that Wallarm can offer. The first is our external attack surface management discovery, where we will find the APIs associated with your domain and subdomains, and then we'll tell you about what protocols are supported, what paths we were able to find, and then we actually assess those APIs. Actually, we assess the security controls protecting those APIs. So if you have a WAF or a WAP in front of them, will tell you how effective it is at preventing attacks from getting to your APIs. And that's a good high level assessment. We also do what we call API leak detection, part of the overall attack surface. So if you have sensitive information about your APIs that has been published in a public web page or in a GitHub repository that's public, we'll go out and look for that data and report those leaks back to you. So that gives you a picture of your external attack surface. And then you can deploy those nodes, which will look at traffic, uh, actually look at your API traffic, and tell you all of the APIs, all of the endpoints, what methods they support, um, give you a risk assessment, it's configurable risk score, tell you which of those API endpoints expose sensitive data so that you can determine whether you have endpoints that shouldn't be exposing that data. You understand where your sensitive data is being exposed. And then you can also upload API specifications to compare them to the environment and shadow, zombie, orphan APIs, what we collectively call rogue APIs, as well as enforce the specification. So if you want to go down that path of enforcement, which really bridges from discovery to protection, you can actually enforce the API specifications in your environment. So if someone sends in a request that doesn't have a parameter that's required or has an extra parameter in the request, you can actually block those based on the specification as well.
All
Chris,
right,
did I
step
miss anything
one.
about discovery?
I, I don't think so. I think, step one, turn the lights on. Step two is stop the bad things from happening.
That's
Tell
right.
us a
Yeah,
little.
lock the
Tell us.
doors. Yeah.
Yeah, tell us a little bit about our protect features.
Yeah, absolutely. So, of course, once you've discovered all of the APIs in your environment, you want to protect them. And we do that with in or out of band detection and then blocking of attacks. So we'll detect attacks like SQL engine or cross-site scripting or path traversal. And in fact, I would break the attacks into two parts, right? There are stateless attacks, which are things that we can detect in a single request. SQL injection is a great example. We can look at one request, we can say this looks like SQL injection, and we can block that request. Um, those are the kinds of attacks I'm talking about when I say stateless. There are also stateful attacks, which are more complicated to detect that occur not in one request, but over the course of a session. So we're also monitoring the whole session and looking for behavior that indicates an attack that's abusive. So those are things like scraping data or account takeover attempts. And we can also detect those, and then we can block them. And we block them, of course, not at the first request, but we block them as the attack develops. So that real-time inline detection and blocking is a key component of the protection piece. I mentioned the API specification enforcement and the GraphQL policy enforcement I mentioned earlier. You can set limitations for GraphQL specifically. You can provide a policy and just block everything that doesn't match. So there are lots of different ways in which we can offer protection in addition to the straightforward blocking of attacks as well.
All right. The next component is about response.
Yeah, so you want to respond to the attacks as well that you see. Whether they're blocked or not, they still might require some response from you. Uh, Part of what we're offering here is that ability to drill into the details and understand what occurred during an attack. I really like to talk about the API session visibility here because we provide you with not just the information about the request that was involved in the attack. We can also provide you with all of the requests that occurred around that actual attack. So you can see not just what the attacker did with one request, but you can see what the attacker did in context. After before and after the path traversal or the SQL injection, if you will. So that's a key part of the response. For those attacks, we provide you with the full request so you can drill into them and see exactly what happened. We also offer those integrations to automate your incident response to allow you to create alerts and generate, events in the other systems you use to respond to attacks. So that integration is a key component for response as well.
And finally, testing.
Yep, in an ideal world, of course, you would remove all of the risk before you push anything to production. We know the world isn't ideal, but we do want to help with that. So there are a couple different ways that Wallarm supports testing. So first of all, we have a clever feature called active threat verification, where you can take the attacks that we see in production, and you can actually rewrite those requests and direct them towards a non-production system. So you can use the attacks that real attackers are sending to test your non-production systems and identify where they're vulnerable, which is really interesting because you can block the actual attack and then use it as a test at the same time, which is pretty cool little tool. We also offer the ability to do testing based on specification. So you can upload an Open API spec, and we will generate a Docker container that you can then run as part of your CI/CD process or pipeline to do testing as part of development as well. So a couple of different ways to incorporate testing into your overall API security process.
All right, I'm looking at the time here, so I'll summarize and kind of wrap up here, because I want to make sure that we're leaving time for questions. So if you're here and you have questions around the API threat landscape or the security model or the maturity model, just please go ahead and put them in there. We'll start addressing all of those. I'll just summarize here, kind of why customers choose Wallarm while you guys are typing those questions. First, I think the thing that makes us stand out more than everybody else is that we block. Like there's a lot of other tools that are great at discovery and finding problems, but that's just more work for you. This is where we are the strongest in the industry right now with inline filtering to stop those attackers. Second, we provide a lot of deployment flexibility. There isn't an environment where we aren't going to be able to help deliver that near zero latency with that type of protection. The bottom left here, privacy first architecture, it's important. There are a lot of API security solutions out there that are gathering this information, putting it in a data lake. You know, your information is less your own at that point. So for us, it's about making sure that everything that we do is very, very secure, very, very protected. And finally, this is one of the fastest growing areas of our business right now is our support services. Obviously, we have great customer support from helping you get deployed, but additionally, Tim mentioned it earlier that we do have a security operations center as well to help organizations monitor their environments and stay on top of their threats. Final summary of just kind of who we are and how to think about us. We've been around for a while. We were founded in 2016. So we do have some of the most experience in the API security industry with the longest track record of securing and blocking those APIs. We've helped shape the space. We do have many patents, some specifically on AI ML approach to threat detection. I mentioned earlier that we are corporate contributors and supporters of the OWASP Foundation. We've contributed to the open source community with projects that have been used over 1 billion times. We have over 80 engineers building new tools. We have that SOC as a service, and lots of great people like Tim on the team here that bring a lot of experience here. And that's why many of these large global brands you see on the right have kind of recognized us and chosen us. I will say we are the only API security vendor that has had customers like those listed there for many, many years. Most API security is relatively new, where it's they've only they're brand new customers. We've had many customers for over 5 years. With that, I'm seeing questions coming in, so I'll leave the link here for the API security checklist. Questions here. I'm gonna start reading them out to you, Tim, and you can jump in here.
Yeah.
Can you recommend API management solutions?
Yeah, so I don't have. I can tell you that the ones we see most frequently in customers. We're obviously not an API management solution. I don't have a specific recommendation, but We definitely see MuleSoft. We also see a lot of Kong. Those are the two that we see most frequently. And they interestingly, they tend to divide, uh, sort of self-select into more and I don't know if it's maturity, but the MuleSoft customers tend to be the ones who are also Salesforce customers, which is not surprising because Salesforce acquires MuleSoft. And the Kong customers tend to be the ones who are more, more interested in open source technology. Kong has an Kong open source and then move to the commercial version as well. So those are the two.
Yeah. All right. Next question is, how is your solution different from your competitors, and how quick does your application mitigate risk from external attacks? I'll take the first part a little bit, and Tim, you can jump onto that and then answer the question around uh, risk mitigation.
Yeah.
Uh, Referring back to my summary before, like our identity isn't blocked. Focus more on observability. They don't existing infrastructure and finding problems for you, not necessarily blocking them. And when they do, there's definitely reacting to it. Additionally, they don't have a lot of the other features that we have. It really depends on what it is that you're looking for. There are some organizations that are just looking for observability, but I think the I would encourage you to try any type of solution out there. There's a reason why we're deploying many more environments holistically. A lot of competitor solutions are very difficult when it comes to deploying across all your different cloud and
Attacks is important immediately. So if you put Wallarm line deployment, it will start blocking attacks as it starts. Doesn't need any configuration or any tuning. Next, it sees is a SQL injection or path traversal. It will it in monitoring mode. So if you don't want it to block, you can configure turned on the are immediate.
all right. The next have follow up and continue putting them in. While our key changes in the API
With no specifications, it will discover all of the endpoints, all of the parameters in both the requests and the responses, and then it will tell you when it's these changes in that baseline that it's established.
yarangiye session yarangiye genza bite
Serverless are both driven by driving simultaneously the development and use of APIs. I think there is part of the evolution of there is also just a straightforward testing capability. I mentioned our open API testing, where you can run a Docker container that tests your APIs as part of the SDLC. So those are two ways. We also have the inventory, the discovery and inventory in testing is important as well. And we definitely have customers who do that. And security is being developed as well.
All right. So next one's kind of an open question. I guess there's lots of answers to this. How does Wallarm integrate?
I just want to say yes to that one. Can I just say yes? I think if the question is how does Wallarm integrate with other tools, there are some built-in integrations that we offer. So you in the UI, you just select that integration. It authenticates, not surprisingly, to an API for whatever product you're integrating with. And we also, of course, are an API first company. So if you want to integrate with Wallarm, there's an API for Wallarm that you could build integration with as
Yeah,
well.
and if you're talking about how does it integrate with an API management
Oh
tool
yeah.
like MuleSoft or Kong, those are also our partners. So like we've there's a lot of these actual partner of, so we work hand in hand with their team, and it's generally not. Next question is: does the wall alarm shut all the traffic or explicitly block the attacker session? Remediation by setting baseline.
So let me see if I understand the first part of that question. I'm not. You can block an IP address, so you can just block take the data center, a list of known malicious IP addresses. You can block those. Those are all ways of blocking traffic, like all the traffic. When we block an attack, we're actually blocking just that one request. So if we see a request with that we detect a SQL injection, we return a 403 for that request. So we block just that one request. So there are different ways of blocking, and you can also set some thresholds. So if, for example, you see you want to set a threshold of, if you see a certain number of attacks per minute from an IP address, stop the individual attacks and just block address. You can set those kinds of thresholds as well. We call those triggers. So there are a couple different ways to do that. The last part of that question of is it possible to put some script as remediation by setting baseline? You can with the web, if I understand that correctly, with the webhook, you can create a trigger that would kick off some kind of a script external to Wallarm. But I think I'd want to understand more about what you're trying to accomplish there to really answer that question in full.
Wow, so many people are still on asking questions, so thank you guys so much for that. You guys are an amazing audience. Thank you
I
so
love it.
much. How important is integrating the provision of the OAS file to the Wallarm as part of the CI/CD process of the API, so you can keep up with the instant changes to the API?
Yeah. So there are two capabilities that are tied to the API spec. One is the detection of rogue APIs, and the other is API enforcement. So if you want to detect rogue APIs, keeping up to date with the spec is valuable, because then every time that spec changes, you can determine whether or not you're a URL for the specs, and it will update them itself, so that you don't have to manually upload them as well.
There's a follow-up question to that one. If you look down on the question list, down one, is there a way to automate the upload?
Oh yeah, sorry, that's what I was just answering. You can point it to a URL, and it will automatically upload the spec from that URL. I think it does it hourly, if I remember correctly.
Gotcha. Licensing options, perpetual or subscription, Tim?
So it's all subscription licensing based on the number. For most of Wallarm, based on anything that processes traffic, it's based on the number of requests per month. So you license a number of requests per month, and that's what we track. The external API discovery, what's called API attack surface management, is licensed by the number of hosts that you discover. Those are the options.
Yeah, and on that leads into kind of the next question here. Do you have a trial or demo package?
Oh,
And
it's my favorite question. There are three different ways to experience Wallarm. The first is so first of all, our documentation is open. If you go to docs.wallarm.com, all our documentation is there. Um, if you go to the main website, you can click the product tour button. That takes you to our playground, which is a read-only environment that you can explore at your convenience. If you want to try it yourself, there is a free version, a free download, which you can find in the documentation. It's limited to a certain number of requests per month, but you can try the capabilities that way. The API attack surface management is available as a free trial from the website as well. That gives you just that external attack surface. And of course, if you want to talk to our salespeople, we're happy to do a proof of concept with you to make sure that it meets your requirements specifically. So lots of different options there for experiencing Wallarm.
all right, that at this point we've come to the end of the questions, but wow, what a lively group. So thank you all of you who jumped in and were asking those questions. We really appreciate them and listening to all of those. Hopefully we answered most of the burning questions on your mind, and hopefully the presentation was useful, educational, informative.
Thanks, everyone.
Recording stopped.
Ipicha Makonde. Minota iranyishu. Yacho.